Welcome to the second section of this video lecture series on Chapter 8 of the Connecting Networks presentation. We've been discussing single area OSPF. The previous section was all about the general characteristics of OSPF. A little bit of single area, a little bit of multi-area, and the things that they have in common. We're going to talk now specifically about implementing single area OSPF. The next subsection of this will be about single area OSPF version 2, which is to say single area OSPF for IPv4. We'll move on to single area OSPFv3, which is to say OSPF for IPv6. So we have a reference topology. As you can see, it's very simple. We've got 3 routers in a ring, fully meshed, so 3 edges, 3 vertices, using serial links, so we don't have to worry about multi-access networks or DR-BDR elections. There's a loopback address that is simulating a link to the cloud. The loopback and the link to the cloud are not in the OSPF area, everything else is. I've got some Class B and Class C /30 addresses for my serial lines. I've got some Class B and some Class C /24 access layer networks. Now, let's see, let me see if I can put myself to go to the next slide. Okay, there. So, if we're the first step with your OSPF configuration is actually to get yourself into OSPF configuration mode. There are other commands used in this mode. You can tell if you're in a version IPv4 router configuration mode because the configuration mode will be config-router. You can tell if you're in IPv6 router configuration mode because the configuration mode will be router-RTR. That seems to be true for all of the v4 and v6 routing protocols that you'll deal with. Now, I don't believe we deal with version 6 IPv for BGP for IPv6 at all, or RIP-NG, which is RIP for IPv6, but we do deal with EIGRP and OSPF for IPv6. Anyway, so you do router OSPF and you give it a process ID. You don't need more than one process ID on the same system. They don't have to match, I don't think, to establish neighbor adjacency with IOSPF in the same way that they have to match for EIGRP. Notice you use your question mark command. Keep that question mark in your back pocket. If there's ever any question about what you can do, what you could do next, what you should do next, what you may do next, use that. And you'll discover some things. You may also discover in Packet Tracer, for example, that certain options that you know are available on real hardware aren't in Packet Tracer. So you can do things like set the priority, set the router ID to priority for, say, for example, your DR-BDR elections. You can set passive interfaces. You can either set a specific interface or you can use the default command to set all of your interfaces passive by default, and then you would use the no passive interface command to set specific interfaces active instead. You use the network command to add networks to the routing domain. You may not want to add every network. Say, for example, you wanted to route to include some of its networks but not others, etc. Specifically, if you add, and we'll talk about this in a minute, in a little while rather, if you have some loopback addresses, you may not want those set up using a network command. The auto cost command will allow you to set the default, the base interface cost, so you can correctly cost out things like fast Ethernet versus gigabit versus 10 Ethernet, 10 gig E. the default bandwidth cost is set at fast Ethernet speeds, which is to say 100 megabits per second, which results in when the system does the division, fast Ethernet links get a cost of 1. 10 gigabit and 10 gig interfaces have a cost that is a fraction of 1, so the system rounds up. The result of that is that the system, unless you tell it to do otherwise, will treat your fast Ethernet and your 10 and your gigabit and your 10 gig interfaces all as though they have the same cost, which is very incorrect. So you're definitely going to want to fix that, particularly if you have a network that you need to account for the other one for fast Ethernet. You've got to definitely do that, or differentiate between gigabit and 10 gig. You got to account for that too. So let's talk about how now you can set a router ID manually. You don't have to, but you can. Now, if you do, there is an order of, if you don't, there is an order of precedence that the device will use on how to pick those. Let's talk about that next. Okay, so when we are picking our router IDs, let's see, this is a good spot to put me. Okay, so when you're picking your router IDs are used to uniquely identify the OSPF router. So definitely make sure there aren't two of the same router ID in the network. That would be bad. Your router ID is a 32-bit number, both for OSPFv2, which is to say IPv4, and OSPFv3, which is to say IPv6. Now, the router ID looks like an IP address, but it isn't one. It is really a 32-bit number in dotted decimal notation. So it's not a router, it's not an IP address. It can be an IP address if, for example, if you don't set a router ID manually, which is like this, configuring it, oh, my apologies. If you do not set it manually, then what the system will do is, if you do not have a router ID specifically configured, it will check to see if you have an IPv4 loopback. And if it does, it'll use that. If it doesn't, and if there's neither a router ID nor a loopback, it will use the highest actively configured IPv4 address. So it can use an IPv4 address, but it doesn't have to. Now, this is not a good, particularly this last option, a configured IPv4 address on a physical interface. What happens if that interface goes down? That interface goes down, it drops off the router's ID changes in the middle of the string, in the middle of its operation. That's a bad thing, because it will advertise a different router ID. Things will get confused. So, because that will also cause the router selection ID process to start over. And then you might get a different result. Either there's a loopback and it picks that, or there's a router ID. Now, the best way to do this is actually to set that router ID. Now, this can also be used in your DR election process if there isn't a priority number. The default priority for all DR elections is 1. The higher the priority, the more likely it is to win that DR election. But if you have no priority and but you do have an IPv4 address in that multi-access network, I believe the highest one will win. So let's talk about configuring that. Okay, so if you have to use, the best bet, of course, is to use your router ID, router-ID, and then x.x.x.x to do the configuration. And let's move me here. Yeah, that's good. You can also see this in show IP protocols. Now, if you want to change this, depending on how you change it, there are a couple different ways to make this thing kick off. The first way is actually if you're setting a router ID, if its router ID was, say, based on a physical address, and you set a router ID specifically, you can do clear OSPF process like this over here. and it will bring the routing process down. It will break all its neighbor adjacencies. It'll bring them right back up again and form new adjacencies with that new router ID. Now, this is true if you're going from a physical interface to a router ID. It is not true if you're going from a physical interface to a loopback address. If you're going from a physical interface being used as your router ID to a loopback being used as your router ID, what you have to do is reload the device. Copy, run, start, reload. It will reboot the device. It will load that loopback address, and then that loopback address will become the new router ID. Now, which is what we're going to talk about next. In the old days, there was no router ID command, so you had to use a loopback interface to provide a stable router ID. Basically, you do something like interface loopback 0, IP address 1.1.1.1 with a mask of /32. Now, do not advertise that network. Don't really use that network for anything. It's not a destination network. It's not there to be pinged, nothing. All you really want to use it for is that router ID selection process. Now, so I'm going to pause right here, and then we're going to talk about how to enable OSPF on these interfaces.